Hey there, Mission Control. Well, I just wanted to do a quick video update tonight to let you know how we're handling one of the solutions that I put out there for the Help Wanted series. If you remember, I did a video on Help Wanted microgreen processing, microgreen growth, and how we can optimize the shelving so that we can actually get as many microgreens as we possibly can in here and meet our requirements. So, just wanted to give you a quick update. Thank you first to everyone that has sent in your comments and your ideas. If you remember, we've talked about flat shelving, we've talked about rotating shelving, quite a few ideas that were submitted, but those two kind of came out on the top. And the winner for this year is actually going to be flat shelving. So I went through and I did pricing on what it would take to buy all this stuff to do the rotating shelves. Remember, that's going to be like a big carousel that just rotates here, and the light, it rotates the greens through the lights and the spray bar. And when you add up everything, the tracking that you'd have to have that goes on the inside, the 12-foot in length shelving units, the shelving tops, the rollers, the bearings, the cables, the connectors, and the motor, the gears for the motor that you would attach to, the sprockets, I should say. All those things, it came out to be about $1,476 per bed to create a rotating shelving system. Now, I'm just one guy doing it, so maybe there's a way to do it cheaper, but the big cost driver, it wasn't the motor, it was actually the tracking that would go all the way around the outside. It was unbelievably expensive to get tracking, like garage door tracking, which I thought would be very cheap, is actually very expensive. And then the second largest contributor were the long shelves. Basically, the 12-foot sections here make it very difficult to find materials that you can easily source that are metal, that you can build shelving like what we needed and make all the cross members and everything. And then I just looked at the time that it would all take, and I considered, well, I'm not a great welder, so this would be nice to cut your teeth on, but really it's already expensive. You'd hate to make a mistake. So I went to a local machine shop, and they charge a reasonable rate, $84 per hour, or at least I assume that's fairly reasonable. And when you add that all up, it's just way too expensive. So you get the savings, if you went with a rotating shelf, you get the savings of less lights, but you add complexity in the mechanical rotation, and then you add a huge amount of cost. So that kicked me over into flat shelving, and what our game plan here is, we actually don't need to completely fill this all the way to the top of the 12-foot section in order to make our financial goals to help fund this operation. What we do need to have is an aquaponics bed, and then at least one row of shelving about this height on all 4 lanes, which is different than what we had before. Originally, we wanted to just have this side of the building, just 2 lanes, dedicated to make the money that we need to make. But because we sat down and we made the decision that, hey, you know, we need the money to be able to pay for all this, so should we turn this building into a microgreen building? And we made the decision to do that. That gave us 4 more lanes, it reduced complexity, and it gave us the shelving space that we needed without having to go hugely vertical or go complicated with the rotating system. So I want to try to visualize that for you here. I guess that I got to back up too is some of you have been very concerned that we're turning away from our mission of providing sustainable food and energy to our local community and communities around the world. That is not what we're doing. I want to be very clear. That is our mission. That's our God-given purpose. That's what has made all of this possible. We are Christians. We are very, very faith-based. This whole thing is happening because we believe that's what He wants us to do, is provide sustainable food and energy. So we're not turning away from that to just go make a profit. What we're trying to do is make enough money to pay for that, because we've looked at grants. We can't find grants that fit for us. We've looked for investors, and we can't find investors that work for us, that are really the triple bottom line type investors. So it's been very difficult to find the money to pay for all this. And even though we have a great bank, a local bank, they came up here, they walked through with us. They would give us loans, but loans without having some form of guaranteed way to pay them off, very, very risky, and that's just not where we want to be right now. So what we want to do is increase the amount of revenue we can get from this building so that we can pay for the mission, which is the TheRealMartian stuff that you've seen. So I know we've talked lately about subscribers and stuff like that, and really great feedback on things I could do better. And one of the things we talked about in there, one of the subscribers put in, is that I go through different topics. And, you know, people watch because they want to see the electronics, but then I shift over to building microgreen shells, and, you know, you're going to lose people that way. And that's a great eye-opener, you know, type of statement. With these microgreens, we're doing it so that we can get the money to go do the other stuff. So I just hope that's very, very clear. So we've calculated everything out. These trays here, they are 10-20 trays, so I think it's about 10 inches wide by about 20 inches long. That they hold material in. We're going to continue to use those. They're one inch deep, and by the time you take into consideration the height of the microgreens plus the lighting that you're going to need underneath of there, you don't need a lot of vertical space to get what you need for these microgreens. You certainly don't need this big aquaponics bed, and that's where I was trying to drive to. Is we're not going to turn away from aquaponics. We're not going to turn everything in here into microgreens. In fact, we're actually going to dramatically increase the amount of aquaponic growing that we're doing that's not microgreens. So right now we've been doing microgreens in aquaponics, and it's just simply not working as well as it should. It's working. These are beautiful. These are radishes right here, and they're absolutely gorgeous. They taste great, good quality, nice stuff is happening there. But one of the problems that we're having is just the amount of water and moisture that's available to these things. Because it's a flood and drain system, we tend to get the greens and the growing media way more wet than what it needs to. So it would be better if it was a top-down spraying system. In addition, if you're doing a top-down spraying system, we've talked to the health department, talked to the Washington State Department of Agriculture, and the verdict is basically out on should you use aquaponic water sprayed from the top down. The general rule of thumb that I've come to understand from the regulators is that you can use fertilized or mineral augmented water or what have you, essentially fish water, as long as it's coming from the bottom up and doesn't touch the edible part of the plant, meaning it only gets the roots, which that's what we're doing right now. But if we switch to a top-down spraying system, which would reduce our potential for fungus and mold and create an even better product, then if you're doing that with fish water, you're spraying the fish water directly onto the growing or the edible part of the plant. So that means you need to send your water off, you need to get it tested, you need to make sure there's no parasites or disease or anything in there. And that's just going to be a bridge too far for us. We don't need to do that for microgreens. So, getting back to the point. This bed and all the grow beds that are the lava rock beds, they are going to be 100% aquaponics, meaning we are going to fill them completely with normal plants like lettuce, basil, stuff like that, leafy greens, English, I can't remember. That's Mrs. Martin's area, but subscriber suggestion nonetheless. We're going to try that out. Broccoli, well not broccoli, sorry. All the leafy vegetables, kale, we're just going to dump them in here and we're going to see how it works. That's the game plan. Just dump and go and just see how well it functions. It should go very well because we've tried that before and we had stuff sprout out. It all worked fine. So, in fact, when we first started microgreens, we didn't even use the trays. We just dumped the stuff in there and we had microgreens. Created a huge mess, but it worked. So all of these grow beds are going to be all aquaponics. So that's 18 grow beds for those keeping track. That's 10 over here on lanes 1 and 2, and 8 over on lanes 3 and 4 for a total of 18. They're all going to be aquaponics. Then somewhere right about in here, about 16 inches up, we're going to put a germination shelf. And we call it the germination shelf because it doesn't need any light. Thank you, Mom. I love you. Great idea. So we're going to put that right here, and then we can stack these trays. Actually, we have lots of room for expansion by doing things this way. We could actually germinate this entire road worth of growing area if we added multiple shelves. We could germinate all of those shelves on a single germination shelf because you can stack microgreen trays when they germinate. In fact, it's recommended. You can check out Curtis Stone's videos. He's got some great videos there on how to grow microgreens, and you can see you can stack quite a few of them high, and it helps ensure a more thorough germination, more consistent germination, more even germination. So anyway, here's this aquaponics, about 16 inches up, maybe a little bit higher, depending on our light solution. You'll have the germination shelf, which will be about, to start with, it's going to be just about 4 inches high is all we're going to do in there. And we can stack a few things, have plenty of room to get in there. And then right about here, you're going to have your microgreen shelf. So right about eye level, we'll try to maximize that so it is more eye level. We have to play with the spacing for the lighting, but we're going to have all the microgreens up on top. Now, I did buy a portable car sensor, and I've gone through and I've checked the lighting in the building. And during the summertime, we do not need LEDs on the microgreens. So we will not need LEDs on the microgreens during the summer. Now, during the winter, that's a different story. So I'm going to have to measure that. So we're going to have a conversation about lighting in a future video again. But right now, during the summertime, during spring, summer, fall, we do not need LED lights for the microgreens to grow. We haven't had any LEDs on these. They've been doing very, very well. And according to the actual PAR sensor, there's plenty of light coming through. 7 micromoles per meter squared per day. That's what you need. We get more than that in here, so it's very good. But in the winter, that'll be a different story. So we're going to have to come up with a mounting system for lights up top. I think we're still going to use the motor going back and forth. But again, a video for a different time. So on the shelving again, this is going to turn into aquaponic beds all the way throughout so that we can continue on our mission of really learning the aquaponics, figuring out how to dial that in, and developing the software and the control system so that we can get that technology to a large amount of people throughout the planet. And then you'll have a germination shelf, again, somewhere right in here, and then you have your microgreen shelf somewhere right in here at eye level, and you just put those microgreens up. Each of these shelves will hold 24 trays put in lengthwise. So the length goes this way, and they'll meet in the middle. You can get 2 sets of trays here, 2 rows on each length. There are going to be a lot of trays in here. So that's our microgreen tray solution for this year. What I like about it is that it's very reconfigurable. So if we wanted to add more vertical space, the money we invest now is not going to be lost. It's very easy just to move things around. If, for example, we wanted to go with 1 germination bed up front to germinate an entire bed worth of stuff, and then you need more lights, you need more watering. So we are going to talk about microgreen watering. I've already alluded to it, but we're not going to use the aquaponic water to spray onto the microgreens. We'll actually use just clean well water. And then the next thing we got to talk about is, are we going to go, we can go with something as simple as this as a manual solution, which is what we shifted to. This is clean well water, and you can just come in and spray this stuff. So you'd be spraying up here. The cool thing about these is they sell these telescoping wands, so you can set them longer, and you can do your entire thing from one spot, and you can just come in here and water all of this in just a few minutes. You can water the entire building in less than 30 minutes. So that's a good use of time. And what that means is we may not try to go for a huge amount of automation, though I think that's the right thing to do, because if we don't do automation, we're not going to be able to travel. We're not going to be able to leave here, except for maybe on a... Actually, no, we won't be able to leave here at all. You have to water. So I think automation is still the right thing, and where I'm leaning is a single supply line down the middle, no moving parts, with the foggers offset on there to cover the microgreens. So I welcome your ideas on the watering. I'm going to go grab a light real fast and show you. This is one of the candidate lights that I found online, of course. I forget how many watts it is, but it puts out more than enough micromoles per meter squared per second to get the 7 micromoles per meter squared per day that we need. If you put on a motor moving back and forth for, I think it's 12 hours, back and forth like this. So I really like these. They're very low wattage, consume hardly any power. So very nice, very low profile as compared to these guys here. and it gets our total coverage, so we spread out that light intensity so it's not just in the middle of the bed. So kind of excited about that. All right, so let's see here. We've gone over microgreen shelving tonight, and we've talked about why we're moving away from the rotating shelves and we're going with the flat shelves. Those shelves have been ordered, and they'll be here in September. So we're shifting around our to-do list a little bit. That's cutting a little bit close for us. As you know, November 11th is our deadline. That's when the first snow fell last year, and I'm guessing it's going to be the same this year. So we're moving towards that. We talked about lighting and the candidate lighting solution, which would be hung up above the microgreens going back and forth. This lighting would also be used for the lettuce. The lettuce needs 17 micromoles per meter squared per day. So we'd probably need 2 of these going on one 12-foot bed, maybe even 3 of them. So we're going to have to figure that one out. And I got a pretty cool off-the-wall idea for lighting that I'll share in another video as well. But I just want to introduce it tonight, so if those that want to do math before I really get into making the decisions, now's your time. I haven't made the decisions yet. I'll do another video on lighting, and then after that I'll probably make my decisions. So, and we talked about watering tonight, probably the main plumb line going down. Oh, let me grab another thing here, kind of unprepared tonight. Okay, for the microgreen watering, one of the questions I was asked is, are you going to have a filter? And if we did the aquaponic water, you definitely need to have this filter. With us going to well water, I'm not so sure, but there is the filter and its brand. See, the water would come, let's see, yeah. Water comes in, water goes out, and this is your drain, so you can clean it. And then this was the original fogger system that I think would still work if we go to the well system. I also got a little high pressure pump. Let me show you that. Okay. This thing opened up here. Sorry, I'm in a rush tonight because not only am I doing this video, but I got to start building grow beds and start a video on that too. I'm a little rushed, a little underprepared, but I wanted to get this out there. I know I've had feedback that I make decisions without talking to you guys all the time, so sometimes it's very difficult. I'm trying though. I hope you guys can see I'm trying. And I guess I'll say it differently. I'm trying to win each one of your subscriptions, and to earn it. Very good feedback. Okay, here is the high pressure pump that I got. Originally I got this because I thought I was going to be using aquaponic water, but now if we go to non-aquaponic water and just well water, this really might be overkill, but it wasn't too expensive. So it's got, looks like a basic inlet here, there, do the inlet, the outlet, and then this could be what we pressurize everything in the building with for the microgreens. So I have water at each of the lanes already. Clean water is there and plumbed in with PEX. So connecting the microgreen watering to it won't be too hard. It's just a matter of, do we need the pump, do we not need the pump? So, okay, I think that's quite a big update. Sorry that it's more just me standing and kind of talking, but again, this is more of the ones where it's, here's your opportunity if you want to do some calculations and figure out, what's going on and try to get ahead of me. Now's the video to do it because I haven't made the decisions on like the watering and the lighting. The decision on the shelving is made, and that's happening. We bought that, but the lighting and everything, that hasn't happened yet. I bought the one microgreen pump, I got the one nozzle to try out, but I'm not done, so I totally welcome ideas on the lighting and the shelving. They're at the right spot because I'm not going to be getting to like the final decision until September-ish. So welcome your comments. Hope you enjoyed this update. If you did, be sure to give us a thumbs up and hit subscribe. That always helps. You can also follow us on Facebook and on Twitter. In the meantime, everybody, this is The Real Martian going to my next project. Out.